to video 2.1, describing a relationship. So today we're going to be talking about the relationship between two variables. When you're describing the relationship between two variables, you have to remember to use DUFs. DUF stands for direction, unusual features, form, and strength. So asking questions and describing the relationship between two variables is a very common FRQ topic. The rubrics are very clear on the expectations, so everything I'm telling you today are part of those expectations. It's very similar to our SOX, but for two variables, and SOX is for one variable. All right, so let's take a look. For direction, you only have two choices. You're either going to have a positive relationship or you're going to have a negative relationship, really, if they're asking you about a scatter plot. Unusual features, here we're talking about outliers. And outliers in a scatter plot does not follow the general trend. And here's what I mean by that. So it's not going to follow the general trend. So if we had a scatter plot and we've got our points in here, but then you had a point outside, we have a general trend going this way. Any points outside the general trend, that's an outlier. The other thing that you could see are clusters. You would want to be sure to reference these two. And so what I mean by a cluster is if we have our scatter plot and we have kind of a group here and then we have more up here. We have a general positive trend, but it's two very distinct clusters. Okay, you would want to mention that. That's pretty unusual looking. Make note of that. So for our form, we're going to go with it's either linear or nonlinear. Because in AP Stats, we're pretty much keeping to just linear regression. So you want to make note whether your scatter plot is linear or nonlinear. And then for strength, we're talking about our correlation here. What is your correlation coefficient? Well, you want to use modifiers such as weak, moderate, or strong. Okay, so I don't have numbers to go with this, but weak, you're looking for a more disorganized scatter to your scatter plot. Moderate is you're starting to see the linear shape take place, but things are still pretty scattered out. And then strong, you're looking, this is obviously a line, and you're looking for that kind of more tight grouping on your data points. Okay, so what I have here is I have a scatter plot with the regression line in place of heating bills compared to the average temperature. It makes sense it has a negative trend because the warmer it is, the less likely you are going to be using the heat inside. Okay, so for your equation, what I want to be sure that you do is you can write the equation like this, but I want you to always rewrite it. What is your y value and what is your x value? And go ahead and plug those in because it helps give a good visual reminder. So the y values are the heat bill. So we're making a prediction on our heat bill. And we're going to use the equation to do that. 273.58 minus 3.6, that's our slope. And our x value is the temperature. Okay, so here's our slope. Now, what I do want to point out is I want us to think back of where slope comes from. Slope comes from the change in y divided by the change in x. So that was your y minus y divided by x minus x. our slope formula. In this context, we're talking about the change in the bills divided by the change in the temperature. And when that happened, we got a number, negative 3.6. Okay, and so it's a whole number that we're having here, so we're just going to put it over 1, and I want us to kind of think about what that means. The change of temperature is 1, meaning 1 degree, because that's how our temperature was measured. And negative 3.6, this is monies, so we're going to talk about that's going to be our monies, and that's going to help us with our interpretation of the slope. So let's kind of take that, and we're going to go down here to our interpret the slope, and then we'll come back to describing our distribution. So when we interpret the slope, we want to, slope is as x changes by 1, what happens to y? So as we get a 1 degree increase in temperature, because that's what happens. So for every 1 degree increase in temperature, what is going to happen? Well, we got this negative 3.6, but remember this is a predicted bill. This isn't an actual bill. So we predict a decrease. The decrease is the negative sign of $3.60 in the heating bill. So every time x increases by 1, y is decreasing an average of 3.6. So we want to be careful. We want to use the word, I like the word predict, because that's what your regression line does, is it makes prediction. You could say it's an average. We have an average decrease. Something along the lines that we're not saying this is what actually happens, because not everybody will have a $3.60 decrease in their bill. That's an average decrease. And so we're just making a prediction here. All right, so let's go back and let's go ahead and describe our distribution. So when we look at it, we have this negative trend. There's nothing outside of the trend, and I don't see any clusters. I'd say it's linear because it's pretty straight here. And then as far as my strength, I'd say it's probably strong, going back to all the things that we talked about. So I'm going to say there's a strong negative linear relationship. Now, we have not included any context here. We've just said strong negative linear relationship between what? Between average temperatures and the heating bill. Okay, now, did we hit everything? We've got strength, we've got direction, we've got form. What we're missing is unusual features. So what we need to be sure to say is with no outliers. Got to mention it. And there's your U. So we've covered our DUFs, D, U, F, S. We have our context with between average temperature and heating bill. So we've done a good job here of getting everything in so we get full points on an FRQ with that kind of question on it. Now, interpret R squared. So R squared tells us how well our line makes a prediction. So to interpret R squared, we're going to change it into a percentage. So 0.989 is 98.9%. What we're going to say is 98.9% of the variation and what is our y, is heating bills. So of the variation in heating bills, can be accounted for by the least square regression line. So 98.9% of the variation in heating bills can be accounted for by the least square regression line. So the variation in your y context right here, that's what you want to put in, and the so this will tell us how well a prediction. So 98.9% of the variation, it's a pretty good predictor of data in this range right here where we collected data. If you get too far outside of that data range, we're starting to talk about extrapolation, and it's not going to be a very good predictor outside of this data range, but within it, it does a pretty good job. Okay, so I have some tips here for you. The first tip has to do with our DUFs. When you're asked to describe the relationship from a scatter plot, you need to be sure to address your DUFs in context. It's a very easy way to get full points on a section, and so you want to make sure you include the direction, unusual features, form, and strength, and context. Our next AP exam tip has to do with writing your regression line equation. When writing the least square regression line equation, be sure to use contextual variables. And remember what I'm meaning by that is what is representing the y context and what is representing the x context. Make sure you go ahead and put those in there. For our third AP tip, that's going to have to do with interpreting your slope. When interpreting your slope, be sure that you state the direction. You want to say either positive or negative or increasing and decreasing. Some indication in that interpretation that whether the slope goes up or if the slope goes down. And our final AP exam tip has to do with r squared. So r squared, you're going to change r squared into a percentage and place a percentage here. So blank percent of the variation in whatever our y context is can be accounted for by our least square regression line. So that's pretty important because you are very likely to see interpret a r squared question. So you want to be sure that you can do that. And sometimes instead of saying r squared, they're going to say this is the coefficient of determination. It's another name for it. And so I just want to be sure that you have an understanding that the coefficient of determination is r squared. All right, hopefully that was helpful. Let me know if you have any questions. See you in class.